Guys, last time we talked about the three kinematic equations, and we said that during the whole course we're going to assume that the acceleration is constant. So if the acceleration is constant, and if we know the acceleration, and if we know that it is constant, and we need to find the velocity, then simply we do the following. Velocity will equal to the acceleration, the integration of the acceleration with respect to time. So if the acceleration is constant, then it goes out of the integration. Any constant goes out of the integration. Then you're doing the integration for t to the power 0 dt, 1 dt. And this integration, if we remember, then it should be equal to a, that's constant, t to the power 1 and divide by 1. So it's at plus constant. So the velocity will equal to acceleration times t plus c. And if we check this equation, the units of that equation, then the units for the left-hand side should equal to the units for the right-hand side. The units for the left-hand side, that's the units for velocity, that's meter per second. If you look at the units for this term, if you check it carefully, the units for this, that's meter per second squared. This is the units for acceleration times time, which is seconds. So if you look at the units for that whole term, the units will be meter per second. If you look meter per second, that's the units for velocity. So this is unit-wise, this is correct. C is a constant, and constant does not mean that it shouldn't have units. Constant can have units. C has to have the same units as V for that equation to be correct. So this is kind of velocity. And which kind of velocity? Let's look. At time equal to 0, V equals to C, right? So at time equal to 0, before we start moving, C is the initial velocity. So I'm going to replace that C by V initial, Vi, or V0, which is V at time equal to 0. So this is the second equation that we should know. First one is A equal to constant. The second one, that's V equal to AT plus V0. So that equation tells us that if we know the initial velocity and the acceleration, we can find the velocity at any time t. Just tell me the time. I will tell you what is the velocity at that time. So that's the second equation. So, and if we know the velocity, if we know that velocity equal to V0, I'm going to rearrange that equation, plus AT, the same equation, this is the same equation. If we know the velocity, can we find the displacement? Yes, we're going to do the same thing again. So actually, we know that displacement, x, will equal to the integration of the velocity with respect to time. So simply, x will equal to the integration of the velocity with respect to time. That's actually the integration for V0 dt plus AT dt. Okay, guys? Okay, guys? Okay. Can we do that integration? I forgot your name. Minna. Can you do that integration? Actually, it's two integrations. If you look at it, we can rewrite, I'm going to just rewrite that equation in a little bit different way. It's the same equation. This is the integration for V0 dt plus the integration of AT dt. I just distributed that mathematical formula onto the two terms. That's all. Minna, I want you to do that term only. That integration only. V0 is a constant. That's what we agreed on a minute ago. V0, that's the initial velocity, and that's constant. And we have agreed also that any constant goes out of the integration, correct? I'm gonna write here, guys. So x will equal to the integration of V0 dt plus the integration of AT dt. I didn't do anything in here, I'm leaving that for now. Minna, we can assume that we have here t to the power of 0. That's 1. We did that trick so many times for now. We did it for few times. T to the power 0. Can you do that integration, Minna? Of course you can. Look, x will equal to V0 times the integration of t to the power 0. What should we do? We add 1 to the power and we divide by the new power. So that's t to the power of 1. I'm not going to write that one. Divided by 1, and I'm not going to write that one as well. So we get that integration. That's it. Plus, Minna, can we do that integration? A, it's out of the integration, that's constant. The integration of t to the power 1 dt, what should we do? We add 1 to the power and divide by the new power. That's it. Did I forget anything? Yes, what did I forget? The constant. Another constant c. It's not the same c. It's another one. I'm going to call it c2, for example. Any other constant. What is the units? What is the unit of that constant? Meter. It has to have the same unit as the left-hand side. At time equal to 0, look at that equation. At time equal to 0, that whole term is 0. That whole term is 0 only at time equal to 0. Then x at time equal to 0 will equal to C2. That means that C2 is the displacement at time equal to 0. It's the initial position. C2 is the initial position. So I can write that C2 as x0. We did that last time. This is what we ended our lecture by last lecture. Again, that was C2, right? At time equal to 0, this term is 0, that term is 0. That means that the position at time equal to 0 equal to C2. Right? So I'm going to replace C2 by the position at time equal to 0. I'm going to give it another simple x0. Because x0 denotes that this is the position at time equal to 0. Okay? Which can be 0 if you start from the origin. x0 can be 0 if you start from the origin. So that's how we got those equations. V equal to V0 plus AT, x equal to x0 plus V0t plus half AT squared. We call those kinematic equations. Those equations should give us all information about any moving object. And I mean by all information, I mean position and velocity. And assuming that the acceleration is constant. Remember that. Those, want to go freshen up a little bit? Are you sure? Those are the three graphs. I assume that acceleration is constant, and I mean acceleration is constant with time. So the object moves with the same acceleration at any time. And this graph represents to us a constant acceleration. At time equal to 0, the acceleration is 2 meters per second squared. at time equal to 1 second, the acceleration is still 2 meters per second squared. The time at time equal to whatever, the acceleration is still 2 meters per second squared. That's for example. So that graph represents to us a constant acceleration. This is the integration of that. If you integrate that graph, you get this. You get an equation for a straight line. Look at that equation. Do you remember what is the equation for a straight line? You remember that? The y equal to mx plus t constant. I'm going to write that equation. V equal to v0t plus at plus v0. Look at those two equations. They are exactly the same. They represent, that equation represents an equation of a straight line where v0 is the intercept, a is the slope of that curve. So the slope of that line will give us the acceleration. So again, this curve in here, this is just the integration of the acceleration, and that curve here, this is a quadratic equation, and this will give us, if you integrate that equation or that curve, you get that curve. Yes. That's v0. At time equal to 0, at time equal to 0, this is time equal to 0, right? This is the initial velocity. The object is not starting from rest. It starts with an initial velocity, v0. Okay? Okay? Okay. Motion in one dimension. Those equations describe to us motion in one direction, in one dimension. So if you have an object that moves along one line, those equations that I just described to you describe the motion in one dimension. This is a good example for a motion in one dimension. What is the initial velocity for that case? 0, because it starts from rest. I let go. I did not give it a push. If you give it a push, then you start with some initial velocity. Okay? So initial velocity in that case, that's 0. Motion in a vertical line has a specific acceleration. That's the acceleration due to gravity. So the acceleration, when the motion is vertical, acceleration will equal to a constant. That constant is 9.8 meter per second squared, and we give it another symbol, that's g. So the constant, it's the acceleration, that in that case it's 9.8 meter per second squared, and that's, we're going to give it another symbol, that's g. Okay, guys? Acceleration due to gravity. How did we know that it's 9.8? I will tell you later, not now. When we go a little bit further, I will prove to you that that acceleration will equal to 9.8, and it's different a little bit from a place to place on Earth. Yes? That's good. What is the acceleration? This is actually, will take us to chapter 3. Acceleration is a vector quantity. What does that mean? Yeah, it has a direction and magnitude. Let's assume that the temperature today is 35 degrees Celsius. When I say temperature today is 35 degrees Celsius, you get all the information you need about how hot is the weather today by just knowing that number. But if I tell you the wind velocity is 5 meters per second, did we get all the information we need about the wind velocity? No, because the direction of the wind velocity is another important information that we should know. Those are two good examples for a scalar quantity, temperature, that the direction does not mean anything to it, does not add anything to it, and vector quantity, wind velocity, that the direction is very important to us. It's a very important information that we should know. Not only how fast is the wind, but also the direction of the wind. That's also something that we should know. What's your name? Mariam or May? Mariam. Okay. Acceleration is a vector quantity. It has a magnitude and direction. So if we're talking about acceleration due to gravity, its magnitude is 9.8 meter per second squared. Its direction, let's find out. Oh, maybe it's different in that place. Same position. It's always pointing down. Well, can I use a book? Can you use the book? Maybe if I tilt it a little bit, maybe it will fall that way. Maybe if I tilt it that way, maybe it will fall that way. Maybe the acceleration depends on the angle you tilt the object with. Let's see. Well, acceleration is smart. It always knows the direction. It's always pointing down. It's always pointing down. This is the direction of the acceleration. I know sometimes in schools they tell you, well, that depends on the motion. If the motion is up, then you take the acceleration negative. If the motion is down, then you take the acceleration positive. Forget that. Forget that. This depends on your coordinate system. So this will take us to chapter 3. But before we go to chapter 3, can we take a few examples on chapter 2? Before I go to coordinate system and what is the direction of velocity and how can we actually scientifically describe the direction of any vector quantity. Can we take a few examples? This is when you throw an object straight up. Which of the following is true about the velocity and the acceleration at the highest point in its path? So if I throw this object up, it goes to a maximum point, then it goes back. It returns back. And I have written 3 statements there. The first one says the velocity and the acceleration at the topmost point is 0. The second one says the velocity does not equal to 0, but the acceleration equals to 0. The third one says the velocity equals to 0, but the acceleration does not equal to 0. So I want you guys to discuss that with your colleague, talk to each other about it. Choose an answer. Do not tell me the answer. Please do not say the answer out loud. Keep it to yourself and let's vote on it. Which one is the correct answer? Okay, so at the maximum point, at the topmost point, which statement is correct? So please do not tell me the answer, just discuss it with your colleague, then let's vote on it, then we'll find the solution later on. Talk to each other. You already know. Can you convince her because she doesn't know? Just tell her what is the right answer and why. Okay, guys, should we vote? Who's in for A? A. 1, 2, 3. Okay. 5, 6, 7. Who's in for B? 2. Who's in for C? Good. So 100. So it's obvious to us that we have some of us have misconception in here because we got The three answers. You gave me the three answers. So let's find who's in for A. A. Can you give us a reason why A is the correct answer?
When I thought about it visually, when it goes up, it just stops, the velocity equals zero, and it doesn't continue to the velocity.
It stops. When it stops, what is the velocity?
Zero.
And what is the acceleration?
Zero.
So if the acceleration is zero, why it will go back? What does the acceleration do? What does the acceleration do? What does the acceleration do? Change the velocity. It slows down the object so that it changes the velocity. The velocity starts with some velocity. I give it an initial velocity, then it slows down, then it stops, but there is still an acceleration, so it goes back. The velocity will start to increase again in the opposite direction. So at the topmost point, what is the velocity? And what is the acceleration? If it's zero, then that object should stop there. It should not go backward. It should not go back. If the acceleration is zero.
So
Yes.
if the acceleration is equal to zero, so it never stops.
If the acceleration is equal, if the acceleration is equal to zero, then what happens? What happens to the velocity? It stays the same. It does not change.
Does that mean that the acceleration is constantly changing?
The acceleration.
It's not constant.
The acceleration is constant.
How is it constant? If it's constant, then shouldn't it continue or constant down?
It's constant down, and the velocity is pointing up. So the acceleration is acting against the velocity, so it slows it down.
Yeah, but when you throw it up, isn't there an acceleration pushing it up also?
No, it's only initial velocity. There is an acceleration pushing it up as long as my hand is pushing it up all the time. Then the object now moves with an acceleration that's provided by my hand. But if you give it a push, what happens is you give it an initial velocity, then the acceleration is the acceleration due to gravity that's acting down. And if there is no earth, what's going to happen to that object? It will continue to accelerate forever. It will never stop. And its velocity, if there is no earth, if there is nothing beneath it, so it will not hit anything. It will continue to accelerate forever. It will never stop. And its velocity will increase by 9.8 meter per second. The velocity will increase by that magnitude each second. Okay, guys? So that's the meaning of acceleration due to gravity and its direction. And that's the solution for it. I want you, this is another other way to solve it actually. Look at the solution, read it, and look at the graphs and try to understand what do the graphs tell you guys. So those are, remember last time I said to you guys, those are the three equations, but there is another one that's, if you remember, that was kind of an assignment for you guys. V squared equal to V0 squared plus 2AX minus X0. Sometimes we write it that way, or we write it delta X. This is the fourth kinematic equation. And I told you guys, try to prove that, and if you cannot prove it by yourself, you will find the proof on the slides or in the book. I'm gonna do the proof with you now. I know that it's Ramadan and too many musalsalat in the TV. So I know that you did not do the assignment, so I'm going to help you out. Just this week. Okay. First equation tells us that acceleration is constant. That's the first equation. Shuhaib. Second equation tells us that V, velocity at any time t equal to V0 plus AT, third equation tells us that the displacement equal to the initial displacement plus initial velocity times t plus 1/2 at squared. But do you remember that equation? Do you remember that equation? This is similar to anything that you see on the board, that equation. Is that similar to anything that you see on the board? Yeah, it's the second one. It's, I just rearranged the second one. If you look at the second equation, V equal to V0 plus AT. If you take V0 to the other side, you get V minus V0. If you divide by T, you get the acceleration. If you divide by the acceleration, you get the time. So that equation is exactly that equation. Okay, guys? It's exactly the same. Do you agree? Should I do it on the board? Do you agree? Should I do it on the board? Do you want me to do it on the board? Okay. Plug T in this equation. So in this equation, every time I see T, I'm going to remove it. I'm going to put the value for this. So in this equation, every time I see T, I'm going to replace it by this amount. And if we do this, you get a very ugly equation. But if you simplify it, you get a very ugly equation. But if you simplify it, trust me, you get this. So I believe you guys that you can go from here to there. Can you do that? It's an assignment. I will get that on Thursday. Okay, to go from this step to that step. I know that's silly sometimes for some people. That is very easy. But I just want you to do it. From this equation, try to prove that. No, give it me in class on Thursday. Yeah, all the presentations are on Blackboard. Yes. I know, by the average velocity. Okay, guys, they used to tell you in ثانوية عامة الإجابات النموذجية. There's nothing called the perfect answer. There's a right answer and a wrong answer, and the right answer can be reached by so many methods, so many ways. All of them are correct. The answer that I like, the answer that I did not think about. But that does not make it a better answer. Okay, guys? So I know that there are other ways to reach the same equation. As long as you get the same equation, and as long as you follow correct steps, then it's correct. Yes.
So we should get this equation and do this.
From that equation, get that. Okay, this is the summary of what we have studied so far. We have proven those equations, and we have got that equation that tells us the velocity, the final velocity minna, equal to the final velocity square minus the initial velocity square equal to 2a times x minus x0. This is only, those equations are only valid if the acceleration is constant. If the acceleration is not constant, those equations are not valid. Those two? No.
And the constant like 5, 6, 7. 9.8 the square دي معناها a squared.
No. 9.8 meter per second square, it means the velocity change by 9.8 meter per second each second. The velocity. There's a change in the velocity, not the acceleration. The meaning of acceleration, that if you have an acceleration, that means that the velocity will change. It can increase. If it increases, then we call it acceleration. And if it decreases, the velocity, then we call it deceleration. Right? That's what we have studied in high school. So if there is an acceleration, then the velocity will change. This is the physical meaning of acceleration. So assume that I'm going to skip that, guys. I'm going to skip that. Okay, let's look at that problem. We have a car that's traveling with the initial velocity v0. At time equal to 0, the driver puts on the brakes, which slows the car at a rate of AB. The car will slow down by a rate equal to AB. What's that AB? It's acceleration. Slows down means that the velocity will change, and the velocity will change by some rate. This is the rate of change of the velocity. That's acceleration. So that's AB. So we need to find out at what time does the car stop. Find the time the car will stop at. So what to do? You're moving with a you start to move with you're moving with a constant velocity, then suddenly you hit the brakes, then the car will slow down, then it will stop after some time.
Can't you use that equation that we did?
Which one? You have all of them on the board.
What if T equals the velocity minus the initial velocity?
I forgot your name. Farida, right? Farida. Okay. Which equation?
T equals the velocity minus the initial velocity over acceleration.
Oh, yes, that's correct. That's the right equation. V equal to V0 plus AT. That's the same thing. Okay. We're going to use that equation. Farida saying, can we use that equation? Maybe. Let's find out. What's V0? Is it given? Yes, that's V0. It's given by V0. He told us that it moves with the initial velocity V0. What is the final velocity? What? How come? How do you know that it's 0? It stops at the end. And if it stops at the end, then the final velocity is going to equal to 0 plus AT. What is the acceleration of that car? AB. So time t, it will stop after time t, which is equal to negative. Negative time? Acceleration is negative, thank you. Acceleration is negative. Why do we have a negative acceleration? Because the car slows down. Because the car slows down. Okay, guys? So that was a good information to know. If it stops after time equal to V0 over AB, how long will it travel before it stops? X0 plus V0t plus 1/2 AT squared. Okay? I'm going to assume that since we have no information about the initial position, so I'm going to assume that the initial position is 0. Oh yeah, on the graph. That's on my solution. Yeah. So what's V0? It's a given. What is the time? So let's replace that. X will equal to V0 plus time. V0 divided by AB. Correct? I'm going to replace the time by its value plus 1/2 AB times time squared. Right, guys? Right? So this is V0 squared over AB, correct? I just replace the time by its value. Then simplify that equation. That's simple. Then simplify that equation. And if you do that, this is the first part that we have solved together, and this is the second part. Okay. Then we can assume some number to get some numerical value, but that is not important. So how can we solve any problem in this chapter? Simply read the problem carefully. Sometimes you have the information hidden, like It starts from rest. That means that the initial velocity is 0. It stops at the end. That means that the final velocity is 0. So read the problem carefully. Watch out for your units. Sometimes I give you the acceleration in meter per second squared, and I give you the distances in centimeters. So watch out for your units. Convert everything to the MKS system. Meter, kilogram, second. MKS, meter, kilogram, second system. Understand the limits. What are the limits in this chapter? Constant acceleration. We're dealing with constant acceleration. Okay, guys? So that's everything in... We're not going to study that. That's everything in chapter 2. I'm going to skip that. Next time we're going to have to get that presentation for you guys. That's, I was telling you that old joke, if you have a feather and an elephant and you let them go from a very high building, which one will reach the ground first? Ignoring air resistance, that's we know that if we ignore air resistance, they will reach at the same time. And next time we'll get that demonstration in class and we'll show it to you. I'm sorry, we'll not be able to get an elephant though. Okay, guys, but look at this problem in here. I want you to spend 3 minutes solving that problem, guys. 3 minutes. You can solve it in a group, so you can discuss the problem with your colleague, with your neighbor. And please do discuss it with your colleague. It's more beneficial if you discuss the problem with your colleague. You learn something and you teach him something. That's what we want to know. You drop something from a height, then it hits the ground. Just before it hits the ground, how long will it take to reach the ground if that height is 1,000 meters? And what is the velocity just before it hits the ground? Minna, I want to see your solution. So solve and ask. You can ask me whatever you want. Yes. Are you done? Okay.
Would I just take the height and divide it by the acceleration due to gravity?
Why?
To get the time.
To get the
Seconds.
time. How did you get that equation?
I don't know.
Oh, you should know.
This makes sense.
It has to make, well, why it makes sense? Why does it make sense to you? You should prove it to me, at least. But all what we know, those 3 famous equations, let me put them down on the board. All what we know is the following. That's everything we know. Then we need to translate that problem into information. What information do we have? Translate that on your paper. then let's try to solve it together. Are you done? Good. Mariam, are you done? Not yet? Are you done? Good. Muhammad, are you done? Muhammad, right? Ahmed, are you done? Yes. Okay, can we translate that equation from English into useful English? Okay, what information do we have? The V naught equal to 0. Initial velocity equal to 0. Initial velocity equals to 0. How did you know that? He dropped it. Just let go of it. So that means that initial velocity equal to 0. That's one. Got one good information. What else? Acceleration. And the total distance x equal to 1,000 meters. Okay. What do we need? We need time and final velocity. Okay, let's look at the equations. Do you have x0, by the way? Initial position? I'm going to assume that this is my initial position. X0? Yes. Yes, like the one in the assignment, the first one. X0 is not going to be 0. First one. Yeah. I'm not sure about the second one because I don't remember the second one, the train, and when you're trying to catch the train. For the train, the initial velocity is 0, but for you, the initial velocity is 0 plus 30, something like that. It's plus 30, something like that. I don't really remember, but yes. But let's concentrate in here before we go to the assignment. Okay, so we need to find the time. How long will it take before it reaches the ground?
You could start by getting the velocity.
Of course, why not? Can we start by getting the velocity? Why not? This equation? Okay, which one? What's v squared? We don't know. What is v initial squared? 0. What is the acceleration? What's delta x? Meter. 140 meters per second. So if we know the velocity, can we get the time? And if we do that, what will be the time? So we take the velocity, we will put it in here, we get the time. That's one way to solve the problem. That's correct. That's good. That's one way. No. Oh, you can do that. Yes. I just want to postpone that for a little bit till we go to chapter 3. But Farid is saying, can we have that position to be 1,000? Yes. Yes, as long as that means that you have chosen your origin, your 0 point is to be the ground. Okay?
But doesn't that mean that here, when it says x minus x,
0.
0,
Hmm.
it's not 1,000 minus 1,000 is 0?
That means that also you have to take 9.8 to be negative 9.8. Okay? Actually, so I'm going to tell you how should we solve that problem. we have to choose, first of all, this is a good way to introduce what we call it a coordinate system. I have to choose where is my 0 point, first of all. So I'm going to choose my 0 point to be at the ground. Farida? That's 0. That's it. That's x0 equal to 0 at here. Okay? This is positive y-axis. So I'm going to choose up to be positive y-axis, this to be positive x-axis for that problem. But since the motion is only in one dimension, then the x-axis will not mean anything to us. Okay, then we need to find the time first. We need to find the time. So I'm going to use that equation. I'm going to use a different way. Who said that? So forgive us for that. We're going to use a different way than your way. X will equal to x0 plus v0 t plus 1/2 a t squared. X 1000 equal to x0, which is 0, plus initial velocity is equal to 0, to be positive. Now, x equal to blah, blah, blah. Guys, I want to put the right. I want to put the right direction. X, that's a vector quantity. Is that up or down? This is y equal to 0. If y is up, then it means that y is positive, it's down, that line, then it's negative. That 1,000 meters, that's up or down, that line, it's up there. So that's positive. Equal to 0 plus v initial, that's 0, t plus 1/2 acceleration. Times t squared. Okay, guys? So this will take us to introduce us to what we call it a coordinate system. We have to choose a coordinate system. We have to choose an origin, where is my 0 point. Up is positive, down is negative. So if the object is moving up, then it has a positive velocity. If it's moving down, then it has a negative velocity. Okay, guys? So we'll stop here. We'll continue. I believe that you can solve the assignment. You can solve the assignment now. I'll be in my office all day tomorrow, and on Wednesday, if you need anything, you please come. Please feel free to come by and ask me anything about the problem. 1106 SSE.